10 scientific mysteries continue to baffle the world's leading researchers in 2025. Some have puzzled humanity for millennia, while others emerged from cutting-edge discoveries just last year. In 2024, astronomers detected ASCAP J1832-0911, an object emitting bright flashes of radio waves and X-rays every 44 minutes, a phenomenon that represents an entirely new class of cosmic objects we cannot explain. These aren't obscure academic questions. They're fundamental problems that could reshape our understanding of physics and biology. We'll start at the dawn of everything, where cosmic expansion theories still fail, then zoom in on our cosmic backyard before venturing to the farthest reaches of space. The creation of the universe, updated Big Bang theories. How did everything begin? This question has haunted humanity since the first conscious minds gazed upward at the night sky. We've built the most sophisticated instruments ever conceived to peer back through time itself, yet the ultimate origin of existence remains stubbornly beyond our grasp. The James Webb Space Telescope delivered unprecedented data throughout 2024 and into 2025, revealing galaxies that formed just 400 million years after the Big Bang. Webb's 2024 data showed several galaxies at 400 million years after the Big Bang with stellar masses up to 100 billion suns, more mature than models allow. These observations confirmed that cosmic expansion happened exactly as predicted, but they also created new problems. These early galaxies appeared too massive and too organized for their age. Planck's CMB data gives us a 13.8 billion year estimate with plus or minus 40 million year accuracy. But this precision makes the deeper mystery more acute. We can trace cosmic history back to when the universe was smaller than a proton, yet we cannot explain what came before that moment or what caused the initial expansion. Eternal inflation theory suggests our Big Bang was just one bubble in an endless foam of expanding universes. Even eternal inflation models admit a beginning. Goose calls it a cosmological stuck point. This highlights that we still need a cause for the start. Meanwhile, cyclic universe models propose that our cosmos goes through endless cycles of expansion and contraction, making our Big Bang just the latest in an infinite series of cosmic rebirths. Quantum field theory offers a different approach to the initial singularity problem. New proposals suggest that quantum vacuum fluctuations could spontaneously create space, time, and matter from absolutely nothing. These theories mathematically describe how the fundamental fields of physics might bootstrap themselves into existence, generating the energy density needed for cosmic inflation. The question, why is there something rather than nothing, grows more perplexing as our knowledge increases. Philosophers and physicists have grappled with this puzzle for centuries, but modern cosmology makes it more urgent. Every equation we write assumes the existence of mathematical relationships, physical laws, and the very concept of existence itself. Multiverse theories complicate creation stories further. If our universe is just one of countless others, each with different physical constants and histories, then asking about the creation becomes meaningless. Goose warns multiverse scenarios still require beginning, so the origin remains unsolved. Even with gravitational wave detectors, particle accelerators, and space telescopes that can see nearly to the beginning of time, we face a fundamental barrier. The laws of physics break down at the moment of creation. General relativity predicts infinite density and curvature, while quantum mechanics suggests that space and time themselves emerge from more fundamental processes we cannot yet comprehend. Current physics may be inherently incapable of solving the creation mystery. The very tools we use to investigate reality might be products of the process we're trying to explain. This creates an endless loop where we use the consequences of creation to understand creation itself. Yet even as we struggle with cosmic origins, we face an equally perplexing puzzle about the very substance that fills our universe. Dark Matter's True Nature 2025 detection attempts. 85% of all matter in the universe is completely invisible to us. This invisible substance, called dark matter, outweighs all the stars, planets, and gas clouds we can see by more than 5 to 1. Yet after decades of intensive searching, scientists have never directly detected a single dark matter particle. The Lux Zeppelin detector, buried nearly a mile underground in South Dakota, represents the most sensitive dark matter hunting experiment ever built. Throughout 2025, this massive detector filled with liquid xenon has been monitoring for the faint signal that would indicate a dark matter particle colliding with an atomic nucleus. The underground location shields the detector from cosmic rays and X-rays. Other interference, creating the quietest environment possible for this cosmic ghost hunt. Despite running continuously with 1,000 times increased sensitivity over Xenon 1T, Lux Zeppelin has detected nothing beyond ordinary background radiation. Scientists know dark matter must exist because of its gravitational effects on visible matter. Galaxies rotate too fast to hold together based on the mass of their stars alone. Galaxy clusters bend light from distant objects more than they should. Computer simulations of cosmic structure formation only work when researchers include 5 times more dark matter than ordinary matter. The gravitational signatures are undeniable, but the particles themselves remain stubbornly hidden. The most promising candidates for dark matter particles have failed to appear in detectors. Null results at current cross-section limits below 10 to the power of negative 47 cm client for 40 GeV WIMPs pushes scientists towards sub-GeV candidates. Axions, hypothetical particles that could solve problems in both particle physics and cosmology, have similarly evaded detection despite specialized experiments designed to catch them. Each negative result forces scientists to consider more exotic possibilities. Modified gravity theories offer alternatives to dark matter, though they face significant challenges. Modified Newtonian dynamics explains galaxy rotation curves, but struggles with galaxy cluster observations, limiting its acceptance compared to dark matter models. Emergent gravity theory suggests that gravitational effects arise from quantum entanglement in ways that could eliminate the need for dark matter entirely. The Euclid Space Telescope completed its first comprehensive dark matter map in 2024, revealing unexpected structures and how this invisible matter is distributed across the universe. Euclid's 2025 data reveal clumped dark matter filaments thicker than predicted, suggesting self-interaction or novel physics. Some regions show less dark matter than expected, while others contain surprising concentrations. Recent proposals suggest dark matter might have complex self-interactions that we have not considered. If dark matter particles can collide with each other, scatter, or even form bound states, this could explain the unusual distributions Euclid observed. This self-interacting dark matter could create cores in galaxy centers and alter the predicted structure of cosmic web filaments. Primordial black holes formed in the early universe represent another dark matter candidate gaining attention. Current studies limit primordial black hole mass to 10 carat 17 to 10 carat 23 grams, though constraints remain uncertain. Recent gravitational wave detections have renewed interest in this possibility. Artificial intelligence systems are analyzing vast datasets from dark matter simulations in 2025, searching for patterns that human researchers might miss. Phantom data from Lux showed noise patterns matched atmospheric muons, not dark matter, prompting new machine learning methods to isolate true signals. These AI systems process thousands of simulation results simultaneously, testing scenarios that would take human scientists years to evaluate. After more than 50 years of searching with increasingly sophisticated detectors and theories, we remain as mystified by dark matter as when astronomers first noticed galaxies spinning too fast. The universe's most abundant substance continues to hide from us, leaving scientists to wonder if the answer lies in physics we have not yet discovered. Yet, while we struggle to understand the cosmos around us, an equally profound mystery exists much closer to home: consciousness and the hard problem, latest neuroscience. How does 3 pounds of brain tissue create the rich inner world of thoughts, emotions, and experiences that define human existence? This question represents neuroscience's greatest challenge, explaining how electrical impulses between neurons somehow generate the subjective experience of being conscious. fMRI and optogenetics tracked activity clusters in brain circuits with unprecedented precision in 2025. High-resolution fMRI scanners can now monitor neural networks firing in real time, while new optogenetic techniques allow researchers to control specific brain circuits with light. These technologies reveal intricate networks of communication across different brain regions, but they still cannot explain why these neural processes feel like anything at all. The hard problem of consciousness, coined by philosopher David Chalmers, remains as puzzling today as when first articulated. Scientists can explain how the brain processes information, responds to stimuli, and controls behavior. These are the easy problems of consciousness. But explaining why we have subjective experiences, why seeing red feels different from hearing music, or why physical pain creates genuine suffering continues to elude scientific explanation. The Perturbational Complexity Index represents a breakthrough. Attempt to measure consciousness objectively. This technique sends magnetic pulses into the brain and measures how the resultant neural activity spreads and integrates across different regions. Conscious patients show complex, sustained patterns of neural response, while unconscious patients exhibit simple, localized activity. Researchers are now using PCI to assess consciousness in patients with severe brain injuries, potentially revolutionizing how we understand disorders of consciousness. Psychedelic research has exploded in 2024, providing unprecedented insights into altered states of consciousness. Studies with psilocybin, LSD, and DMT show that these substances temporarily disrupt the brain's default mode network, a collection of regions active during rest and self-reflection. Participants report profound changes in subjective experience, including dissolution of the sense of self in mystical experiences. These findings suggest that normal consciousness might be just one possible configuration of brain activity. Two major theories compete to explain consciousness. Global workspace theory proposes that consciousness arises when information becomes globally available across the brain through a network of interconnected regions. Integrated information theory takes a different approach, suggesting that consciousness corresponds to integrated information, the amount of information generated by a system above and beyond its parts. Both theories make testable predictions, but neither fully explains why integrated information or global access should create subjective experience. Artificial intelligence systems in 2025 can engage in sophisticated conversations, solve complex problems, and even create art. Large language models process information in ways that sometimes mirror human cognition, yet they lack genuine subjective experience. These systems respond to questions about consciousness, but they have no inner mental life. The gap between information processing and genuine experience remains as wide as ever. Split brain research continues revealing surprising aspects of conscious unity. Patients who have had their corpus callosum severed to treat epilepsy sometimes show conflicting behaviors between their left and right hemispheres. Recent studies suggest that consciousness might be more fragmented than we assume, even in healthy brains. These findings challenge our intuitive sense that consciousness is unified and indivisible. The philosophical implications are profound. If consciousness cannot be reduced to neural activity, it might represent a fundamental aspect of reality that science cannot fully capture. Some researchers propose that consciousness might be the one thing that will always remain beyond complete scientific explanation. Yet, while we struggle to understand the nature of inner experience, other mysteries manifest in ways that affect people's daily lives in very tangible ways. The Taos Hum new 2024 investigation results. Residents of Taos, New Mexico describe it as a persistent, maddening sound that invades their homes and minds. This low-frequency hum disrupts sleep, triggers headaches, and creates psychological distress for those unfortunate enough to hear it. The sound becomes more noticeable indoors and at night, turning what should be peaceful environments into sources of torment. Some residents have lived with this acoustic torture for decades, unable to escape the constant droning that seems to emanate from nowhere and everywhere at once. Local and global hum reports prompt investigations into infrasound and electromagnetic origins, though no consensus has emerged. Researchers used infrasound sensors in GPS-linked microphones in 2018 to 2023 to map hum reports but found no clear source. Teams of acoustics experts worked around the clock, collecting data during different weather conditions, times of day, and seasonal variations. Despite intensive monitoring, the source of the hum remained elusive. The hum affects roughly 2% of the population, a small but significant group that experiences genuine physical and psychological suffering. These individuals report chronic insomnia, persistent headaches, and mounting psychological distress that can lead to anxiety and depression. The selectivity of the phenomenon puzzles researchers. Why can some people hear the hum clearly while others standing next to them detect nothing? Medical examinations of affected individuals show no consistent hearing abnormalities or neurological conditions that might explain their sensitivity. Hum investigations consider geological, industrial, and auditory pathologies but remain inconclusive. New Mexico's complex geological structure, including the Rio Grande Rift system, could generate low-frequency vibrations through underground rock formations. Industrial sources like power lines, transformers, and manufacturing facilities produce electromagnetic fields and mechanical vibrations that might contribute to the phenomenon. Some researchers explore whether certain individuals possess heightened sensitivity to these environmental factors. Global Hum reports since 1993 in Taos, Auckland, and Windsor have been the subject of tinnitus machinery and seismic hypotheses. The Australian cases emerged near mining operations, while Canadian reports clustered around areas with significant underground geological activity. These global occurrences suggest that Taos Hum represents one instance of a broader phenomenon affecting multiple locations with seemingly different environmental conditions. Traditional audio equipment consistently fails to detect the frequencies that sufferers clearly hear. Standard microphones and recording devices cannot capture the specific characteristics of the hum, leading to frustration among both researchers and affected residents. This technical limitation has complicated scientific investigation and contributed to skepticism about the phenomenon's reality. Some studies suggest placebo or frisson responses could explain individual reports, though researchers documented measurable physiological effects in people exposed to the hum, including elevated stress hormones and disrupted sleep patterns. These objective measurements prove the hum creates genuine physical responses rather than purely psychological reactions. Despite sophisticated investigations utilizing cutting-edge technology and multidisciplinary research approaches, the Taos Hum remains as mysterious as when residents first reported it decades ago. While terrestrial mysteries like the hum confound scientists on Earth, equally puzzling signals reach us from the depths of space itself. Fast radio bursts, recent breakthrough discoveries. Millisecond bursts of radio energy from deep space have captivated astronomers since their first detection in 2007. These fast radio bursts arrive without warning, releasing tremendous amounts of energy in the blink of an eye before vanishing completely. Each burst lasts mere milliseconds, yet scientists estimate they occur roughly once every 10 seconds somewhere in the observable universe. The closest fast radio burst ever detected was discovered in 2024, originating from a galaxy just 3 billion light-years away. This relatively nearby burst provided unprecedented detail about the signal's characteristics and properties. Previous detections came from much more distant galaxies, making detailed analysis extremely challenging. The proximity of this burst allowed astronomers to study its structure with remarkable precision using multiple telescopes simultaneously. These cosmic events release staggering amounts of energy in incredibly short time frames. A single fast radio burst can emit more energy in milliseconds than our sun produces over several days of continuous nuclear fusion. To put this in perspective, the energy output equals what our sun generates during approximately 80 years of normal operation, compressed into a time span shorter than a human heartbeat. Scientists achieved a major breakthrough with the identification of FRB 2020-0120, E's source as a magnetar within a nearby galaxy. Magnetars are neutron stars possessing magnetic fields, trillions of times stronger than Earth's. These exotic objects represent some of the most extreme environments in the universe, where matter exists in states impossible to recreate on Earth. The magnetar connection provides crucial insights into the physical processes that might generate these powerful radio emissions. Some fast radio bursts repeat at irregular intervals while others appear only once, creating a puzzle that defies current theoretical models. Repeating bursts suggest their sources survived the initial emission event, while one-time bursts might indicate catastrophic destruction of their source objects. This fundamental difference challenges astronomers to develop separate explanations for what might actually be different types of phenomena. Advanced observations in 2024 detected fast radio bursts with complex polarization patterns revealing information about their source environments. These patterns indicate the presence of extreme magnetic fields that twist and bend radio waves as they travel through space. The polarization signatures suggest some bursts originate near black holes or in the aftermath of neutron star collisions where magnetic fields reach extraordinary intensities. The Canadian Hydrogen Intensity Mapping Experiment Telescope Array has cataloged over 1,000 fast radio bursts, revealing unexpected diversity in their properties. Some bursts show complex internal structure with multiple peaks, while others appear as simple pulses. The frequency ranges, durations, and repetition patterns vary dramatically, suggesting multiple mechanisms might be responsible for generating these signals. A controversial possibility exists that some fast radio bursts could represent artificial signals from advanced civilizations. While most scientists remain skeptical, the burst characteristics do not completely rule out technological origins. The energy requirements would demand technology far beyond current human capabilities, making this explanation highly speculative. Despite remarkable progress in detection and analysis, the fundamental mechanism producing fast radio bursts remains completely unknown. Yet, while we search for answers in distant galaxies, some of science's most perplexing mysteries exist much closer to home, hidden in the most ordinary aspects of human biology. Fingerprint Evolution 2025 Genetic Research. Every human being possesses completely unique fingerprints, yet science still cannot explain why we evolved these distinctive ridge patterns in the first place. These swirling lines and loops that cover our fingertips serve as perfect identification markers, but evolution did not anticipate the invention of forensic science. The mystery deepens when we consider that no two people share identical fingerprints, not even identical twins who develop from the same fertilized egg. Genetic studies conducted throughout 2025 have identified specific genes that control fingerprint ridge formation during fetal development. Researchers discovered that particular gene variants influence how skin cells organize themselves into ridge patterns between the 10th and 17th weeks of pregnancy. These genes regulate the expression of proteins that guide cellular migration and differentiation in developing fingertip skin. The research reveals that fingerprint formation follows predictable genetic pathways, yet the final patterns remain unique to each individual due to complex interactions between multiple genes. Experiments testing whether fingerprints actually improve grip have produced surprisingly mixed results that challenge conventional assumptions. Some laboratory studies show that fingerprint ridges enhance friction between fingertips and smooth surfaces, similar to tire treads on wet pavement. However, other carefully controlled experiments found no significant improvement in gripping ability when comparing smooth fingertips to ridged ones. These contradictory findings suggest that grip enhancement might not be the primary evolutionary purpose of fingerprints. New research on fingerprint sensitivity proposes that these ridge patterns might amplify vibrations for enhanced touch perception. Scientists discovered that fingerprint ridges create resonance effects when fingers contact textured surfaces, potentially magnifying subtle vibrations that help us detect fine textures and surface irregularities. This amplification could explain why humans possess such remarkable tactile sensitivity compared to other mammals with smooth fingertips. Comparative studies with other primates reveal that fingerprint complexity correlates directly with manual dexterity across different species. Humans possess the most complex fingerprint patterns and demonstrate the highest levels of fine motor control. Great apes show moderately complex ridge patterns with correspondingly advanced manipulation abilities. This correlation suggests that fingerprint evolution relates to the development of precise hand movements. A significant 2024 discovery revealed that fingerprint patterns can indicate susceptibility to certain genetic conditions. Researchers found that specific ridge configurations correlate with increased risk for congenital heart defects, chromosomal abnormalities, and developmental disorders. This connection between fingerprint patterns and genetic health opens new possibilities for early medical screening using non-invasive fingerprint analysis. Despite sharing identical DNA, identical twins develop different fingerprints during fetal development. This phenomenon occurs because fingerprint formation depends on environmental factors within the womb, including finger position, amniotic fluid flow, and pressure from surrounding tissues. These random environmental influences create unique ridge patterns even when genetic instructions remain identical. Despite remarkable genetic breakthroughs revealing the biological mechanisms of fingerprint formation, the evolutionary purpose of these unique patterns remains an open question. Yet, while we struggle to understand why our bodies develop these mysterious ridges, medical researchers have discovered that our minds possess the placebo effect, abilities to heal our bodies through belief alone. Fake treatments produce real medical improvements in ways that continue to baffle researchers worldwide. Sugar pills relieve genuine pain. Saline injections reduce nausea. Sham surgeries heal chronic conditions. These aren't cases of confused patients or wishful thinking. These are measurable biological changes that occur when people believe they're receiving effective treatment, even when the treatment contains no active ingredients whatsoever. Neuroimaging studies conducted throughout 2024 revealed exactly how placebo treatments activate the brain's natural pain relief systems. Advanced brain scanning technology shows that placebo pills trigger the release of endorphins and other natural painkillers in regions like the prefrontal cortex and periaqueductile gray. These aren't imaginary responses. They represent genuine neurochemical changes that reduce pain perception at the cellular level. The brain literally manufactures its own medicine when it expects relief, creating biological effects that mirror those of actual pharmaceutical drugs. Placebo effects have grown significantly stronger over the past decade, creating serious complications for drug trials. Modern patients show more dramatic improvements from inactive treatments than previous generations, making it increasingly difficult to prove that new medications work better than placebos. Pharmaceutical companies now struggle to demonstrate drug effectiveness because placebo responses have become so powerful that they often rival the effects of active treatments. Open-label placebo trials represent one of medicine's most surprising discoveries. Patients who know they're receiving fake treatments still experience real improvements in their symptoms. Researchers inform participants that their pills contain no active ingredients, yet these honest placebos continue producing measurable health benefits. This phenomenon challenges everything scientists thought they understood about how placebos work, suggesting that conscious belief in treatment effectiveness isn't necessary for biological responses to occur. Placebo responses vary dramatically between cultures and individuals, revealing complex patterns that researchers are only beginning to understand. Patients in some countries respond more strongly to placebo injections, while others show greater improvement from placebo pills. Individual genetic variations in dopamine and opioid receptors significantly influence placebo effectiveness, creating biological differences in how people respond to expectation-based treatments. Studies on the nocebo effect conducted in 2025 demonstrate how negative expectations can cause real physical harm. Patients who anticipate side effects often experience those exact symptoms, even when receiving inactive treatments. Warning patients about potential adverse reactions can actually trigger the problems doctors hope to prevent, creating a troubling paradox where medical honesty might harm patient outcomes. Research documenting placebo effects in animals challenges purely psychological explanations for this phenomenon. Laboratory animals show measurable improvements from inactive treatments, suggesting that biological mechanisms beyond conscious expectation contribute to placebo responses. Despite understanding some mechanisms behind placebo responses, the full power of expectation over biology remains mysterious. Modern medicine can map brain changes during placebo treatment and identify genetic factors that influence responses, yet the fundamental question persists. The mind's ability to create physical healing through belief alone represents just one example of how reality operates in ways that defy our everyday understanding of cause and effect. Quantum entanglement mechanics' current understanding. Physics reveals even stranger phenomena when particles become connected across impossible distances. Albert Einstein famously dismissed quantum entanglement as spooky action at a distance, refusing to accept that particles could instantly influence each other across vast stretches of space. He believed that hidden variables must explain these apparent connections, maintaining that no information could travel faster than light. Einstein spent years trying to prove that quantum mechanics was incomplete, yet decades later, his spooky action has become one of physics' most rigorously confirmed phenomena. Experiments conducted throughout 2024 achieved quantum entanglement over record-breaking distances, pushing the boundaries of what scientists thought possible. These long-distance entanglement experiments required sophisticated equipment to maintain the delicate quantum connections across enormous spans. Researchers used advanced photon detectors and quantum repeaters to preserve entangled states while photons traveled through optical fibers spanning entire continents. The success of these experiments demonstrates that quantum entanglement works perfectly regardless of the physical separation between particles. When two particles become entangled, measuring one particle instantly determines the state of its partner, no matter how far apart they exist. This instantaneous connection appears to violate the speed of light limit that governs all other physical interactions. If you measure the spin of one entangled electron and find it spinning clockwise, its partner will immediately begin spinning counterclockwise, even if located on the opposite side of the galaxy. The measurement of one particle somehow forces its partner to adopt a complementary state without any apparent signal traveling between them. Scientists continue investigating whether information actually travels between entangled particles during these instantaneous correlations. Some researchers propose that no information transfer occurs. Instead, both particles share a common quantum state that determines their behavior when measured. Others suggest that quantum correlations represent a new type of information exchange that operates outside conventional space-time limitations. The question remains whether entanglement violates causality or simply reveals deeper connections between distant objects. Quantum entanglement fundamentally challenges our understanding of locality and reality itself. Classical physics assumes that objects only influence nearby things through direct physical contact or field interactions. Entanglement suggests that reality might be fundamentally non-local, with distant objects maintaining mysterious connections that transcend spatial separation. Applications in quantum computing and cryptography actively exploit entanglement properties throughout 2025. Quantum computers use entangled qubits to perform calculations impossible with classical systems. Quantum cryptography relies on entanglement to create unbreakable communication channels. Any attempt to intercept entangled messages automatically disrupts the quantum connection, alerting users to security breaches. Recent tests of Bell's inequality continue confirming quantum mechanics' strange predictions about entangled particle correlations. These experiments consistently show that entangled particles violate classical physics expectations, proving that nature operates according to quantum rules rather than classical intuition. Entanglement works perfectly in practice, powering revolutionary technologies and confirming quantum theory's predictions, yet we still lack satisfying explanations for how or why these mysterious connections exist. While quantum mysteries perplex physicists studying the smallest scales of reality, equally puzzling transformations have occurred on planetary scales much closer to home. Mars' missing atmosphere, latest rover data. Mars once flowed with rivers and hosted vast lakes, yet today it exists as a frozen wasteland where liquid water cannot survive on the surface. This dramatic transformation from a potentially habitable world to a barren desert represents one of planetary science's most compelling mysteries. Understanding how Mars lost its life-supporting environment could reveal whether Earth faces a similar fate and help scientists assess the habitability of planets beyond our solar system. The Perseverance rover delivered remarkable evidence throughout 2024, showing ancient river deltas and lake beds scattered across the Martian surface. These geological formations preserve detailed records of flowing water that carved channels, deposited sediments, and created environments where life might have thrived billions of years ago. The rover's instruments analyzed rock layers that formed underwater, revealing chemical signatures of prolonged exposure to liquid water. These discoveries paint a picture of ancient Mars as a world with active weather systems, seasonal flooding, and stable bodies of water that persisted for millions of years. Maven orbiter measurements reveal that Mars continues losing its atmosphere to space at an alarming rate. The spacecraft monitors atmospheric escape in real time, showing how solar wind strips away approximately 100 grams of atmosphere every second. This ongoing loss represents just a fraction of the massive atmospheric depletion that occurred over billions of years. Current escape rates suggest that Mars loses its entire remaining atmosphere every few hundred million years, yet geological evidence indicates the planet once possessed an atmosphere hundreds of times thicker than today. Mars lost its global magnetic field approximately 4 billion years ago, removing the protective shield that deflects charged particles from the solar wind. Without magnetic protection, the solar wind directly interacts with the upper atmosphere, ionizing gas molecules and accelerating them into space. Earth's magnetic field prevents similar atmospheric stripping, but Mars became vulnerable to this relentless erosion process that continues today. Scientists debate whether catastrophic events or gradual erosion caused most of Mars' atmospheric loss. Catastrophic models propose that massive asteroid impacts during the late heavy bombardment rapidly ejected huge amounts of atmosphere into space. Gradual erosion theory suggests that steady solar wind bombardment slowly stripped away atmospheric gases over billions of years. Recent computer simulations indicate that both processes likely contributed, with catastrophic events causing rapid initial loss followed by sustained gradual erosion. Isotope analysis conducted throughout 2025 suggests Mars lost approximately 99% of its original atmosphere. Scientists study ratios of different argon isotopes to reconstruct atmospheric history, as lighter isotopes escape to space more easily than heavier ones. These measurements indicate that ancient Mars possessed an atmosphere thick enough to maintain liquid water and moderate surface temperatures. Despite detailed measurements from multiple spacecraft and rovers, the exact timeline and mechanisms of Mars' atmospheric loss remain unclear. Yet while Mars lost its capacity to support surface water, other worlds in our solar system may harbor vast oceans in unexpected places. Europa's Ocean Composition 2024 telescope findings. Jupiter's moon Europa hides a vast ocean beneath its icy shell, containing more water than scientists initially imagined. This subsurface ocean represents one of the solar system's most intriguing environments, completely hidden from direct observation, yet potentially harboring the conditions necessary for life. The ocean exists in perpetual darkness, sealed beneath miles of frozen water that create an impenetrable barrier between Europa's hidden depths and the vacuum of space. The James Webb Space Telescope detected water vapor plumes erupting from Europa's surface throughout 2024, providing the first direct evidence of active exchange between the hidden ocean and the moon's exterior. These plumes shoot hundreds of miles above Europa's surface, carrying material from the subsurface ocean into space where sophisticated instruments can analyze their composition. The detection required extremely sensitive spectroscopic equipment capable of identifying trace amounts of water vapor against the background of Jupiter's intense radiation environment. Europa's ocean contains twice as much water as all Earth's oceans combined, creating a vast aquatic environment that dwarfs our planet's hydrosphere. This enormous volume of liquid water exists in a sphere roughly 60 to 150 kilometers deep, surrounding Europa's rocky core. The sheer scale of this hidden ocean means it contains more potentially habitable space than all of Earth's seas, rivers, and lakes put together. Spectroscopic analysis of the detected water vapor plumes reveal potential organic compounds within Europa's subsurface ocean. These organic molecules represent the basic building blocks that could support biological processes. The identification of these compounds marks a significant development in understanding Europa's habitability potential, though scientists cannot yet determine whether these molecules result from biological or purely chemical processes. Tidal heating from Jupiter keeps Europa's ocean liquid despite temperatures that would otherwise freeze water solid. Jupiter's immense gravitational field creates tidal forces that flex Europa's interior as the moon orbits the giant planet. This constant flexing generates heat through friction, maintaining liquid conditions in the subsurface ocean for billions of years. The 2024 discovery of what appears to be hydrothermal activity on Europa's ocean floor adds another layer of complexity to this hidden environment. These underwater vents could release heat and chemicals from Europa's rocky interior, creating localized environments similar to Earth's deep-sea hydrothermal systems where life thrives without sunlight. Such activity would provide energy sources that could support biological processes in Europa's dark ocean. Europa now ranks among the most promising places to search for extraterrestrial life based on its combination of liquid water, organic compounds, and energy sources. However, scientists acknowledge that confirming life's existence requires future missions capable of drilling through the icy shell to directly sample the hidden ocean beneath. While Europa's mysteries remain locked beneath miles of ice, other worlds display their puzzling phenomena openly across their atmospheric surfaces. Saturn's Hexagon storm updated weather models. Saturn hosts the solar system's most geometrically perfect storm system. A bizarre six-sided storm at Saturn's North Pole defies everything meteorologists thought they knew about atmospheric dynamics. This geometric weather pattern maintains perfect hexagonal symmetry across thousands of miles, creating one of the most striking and mysterious features in our solar system. Unlike the chaotic, swirling storms we observe on Earth and other planets, Saturn's hexagon displays mathematical precision that seems almost artificial in its regularity. Computer simulations conducted throughout 2024 successfully reproduced the hexagon's formation for the first time in scientific history. These breakthrough models revealed how complex interactions between Saturn's rotating atmosphere and its jet stream create the conditions necessary for hexagonal geometry. The simulations required enormous computational power to model the intricate fluid dynamics operating within Saturn's thick atmosphere. Previous attempts to recreate the hexagon had failed because scientists underestimated the role of vertical atmospheric motion and the precise balance of forces required to maintain geometric stability. The hexagon represents a standing wave pattern within Saturn's jet stream, similar to waves that form in rapidly flowing rivers around obstacles. Saturn's jet stream flows at different speeds at various latitudes, creating shear zones where these atmospheric rivers interact. The hexagonal shape emerges when these flowing atmospheric layers lock into a resonant pattern that reinforces itself through feedback mechanisms. This standing wave maintains its structure through the same principles that create stationary waves in flowing water. Measurements reveal the hexagon spans approximately 20,000 miles across and extends 180 miles deep into Saturn's atmosphere. This colossal scale means the entire Earth could fit comfortably within the hexagon's boundaries with room to spare. The storm's vertical extent equals roughly twice the height of Earth's entire atmosphere. demonstrating the massive three-dimensional structure hidden within Saturn's clouds. The storm's color dramatically changed from blue to gold between 2012 and 2016, as Saturn's season shifted over its 29-year orbital period. This color transformation results from seasonal variations in sunlight exposure that trigger different photochemical reactions in Saturn's upper atmosphere. The blue coloration appeared during Saturn's northern winter when less sunlight reached the polar region, while golden hues emerged as spring brought increased solar radiation. A central vortex spinning at 300 miles per hour dominates the hexagon's eye, creating a massive whirlpool within the geometric storm structure. This high-speed rotation provides the energy necessary to maintain the hexagon's shape and stability over decades of continuous operation. New theories explore how Saturn's magnetic field might contribute to maintaining the storm's geometric precision through electromagnetic forces that complement purely fluid dynamic processes. Evidence confirms the hexagon has remained stable for at least 40 years since its discovery, demonstrating remarkable longevity that exceeds most terrestrial weather phenomena. Despite successfully modeling the hexagon's behavior, scientists still cannot fully explain why this unique geometric storm formed initially. While Saturn's atmospheric mysteries showcase nature's capacity for geometric perfection, other planets in our solar system display equally puzzling characteristics that challenge our understanding of planetary formation. Uranus sideways rotation, new formation theories. Uranus stands alone among the planets in our solar system, rotating on its side with an axial tilt of 98 degrees. While other planets spin like tops with their poles pointing roughly up and down, Uranus rolls along its orbital path like a barrel. This extreme orientation creates the most unusual seasonal patterns in the solar system, where each pole experiences 42 years of continuous sunlight followed by 42 years of complete darkness. Computer simulations conducted throughout 2024 tested various collision scenarios that could have knocked Uranus sideways during its formation. These sophisticated models recreated the chaotic early solar system environment, running thousands of impact simulations with different-sized objects striking Uranus at various angles and velocities. The simulations required massive computational power to accurately model the complex physics of planetary collisions and their long-term effects on rotational dynamics. The leading theory proposes that a Mars-sized object struck Uranus early in its formation, delivering enough energy to tip the planet onto its side. This massive impactor would have approached Uranus during the solar system's violent youth, when planetary embryos regularly collided and merged. The collision would have transferred enormous angular momentum to Uranus, fundamentally altering its spin axis while potentially contributing material that became the planet's ring system and some of its moons. Alternative theories suggest multiple smaller impacts or complex gravitational interactions gradually tilt Uranus over millions of years. These scenarios involve cumulative effects from numerous collisions with smaller objects, each contributing to the planet's eventual sideways orientation. Some models propose that gravitational resonances with other forming planets could have slowly shifted Uranus's rotational axis through orbital migration processes. Uranus's unusual rotation creates a tilted magnetosphere unlike any other planet's magnetic environment. The magnetic field axis tilts 59 degrees from the rotational axis, creating complex interactions with solar wind that produce dynamic auroral displays. This configuration challenges scientists' understanding of how planetary magnetic fields form and evolve, as most theories assume alignment between magnetic and rotational axes. The orbital mechanics of Uranus's moons present another puzzle since they orbit around the planet's equator rather than the original orbital plane. This arrangement suggests the moons formed after Uranus acquired its extreme tilt, possibly from debris created during the hypothetical giant impact. The moon's equatorial orbits indicate they formed within Uranus's new rotational plane rather than preserving the pre-impact orbital configuration. Seasonal effects lasting 21 Earth years create extreme variations in solar heating across Uranus's surface. During solstices, one hemisphere receives direct sunlight while the other remains in complete darkness for decades. These extreme seasonal changes drive atmospheric circulation patterns and temperature gradients that differ dramatically from other planets' weather systems. Despite promising collision theories supported by computer simulations, the exact mechanism that knocked Uranus sideways remains unproven. While planetary formation mysteries persist within our solar system, even stranger objects have visited us from the depths of interstellar space. Oumuamua's True Origin 2025 analysis results. The first confirmed interstellar visitor to our solar system arrived unannounced in 2017, presenting astronomers with their most puzzling cosmic mystery in decades. This cigar-shaped object, named Oumuamua after the Hawaiian word for scout, defied every expectation scientists held about visitors from other star systems. Its elongated form stretched roughly 400 meters long, but only 40 meters wide, creating proportions unlike any asteroid or comet previously observed. Analysis of archived telescope data throughout 2025 revealed new details about Oumuamua's composition using advanced spectroscopic techniques. Scientists examined light reflected from the object's surface, searching for chemical signatures that could reveal its origins. These studies showed that Oumuamua's surface appeared reddish and surprisingly reflective, suggesting it contained materials different from typical solar system objects. The spectroscopic analysis failed to detect water, organic compounds, or other substances commonly found on comets and asteroids. Oumuamua's most perplexing characteristic was its unusual acceleration as it left the solar system, behavior that defied gravitational predictions. The object sped up as it moved away from the sun, gaining velocity in a way that couldn't be explained by gravitational forces alone. This acceleration wasn't consistent with solar radiation pressure effects either, which made the phenomenon even more mysterious. Scientists measured this unexpected boost using precise tracking data from multiple observatories. Several competing theories attempt to explain Oumuamua's strange properties. The nitrogen iceberg hypothesis proposes the object originated from a Pluto-like world where nitrogen ice could survive interstellar travel. The hydrogen iceberg theory suggests it formed from molecular hydrogen that somehow remained solid during its journey through space. A third possibility describes Oumuamua as a fragmented planetesimal debris from a destroyed planet or asteroid that broke apart during its interstellar voyage. Despite accelerating like a comet, Oumuamua showed no visible outgassing or tail formation. Comets typically develop bright tails when solar heating vaporizes surface materials, but Oumuamua remained completely inactive throughout its solar system passage. This absence of observable outgassing challenged scientists' understanding of what could cause the object's mysterious acceleration without producing detectable gas emissions. The controversial alien artifact hypothesis, proposed by Harvard astronomer Avi Loeb, suggests Oumuamua could represent technology from advanced civilization. This theory proposes the object might be an artificial light sail probe sent by extraterrestrial intelligence. However, most scientists reject this explanation due to lack of supporting evidence and the challenges of explaining the object's properties through artificial means. Statistical models predict that telescopes should detect similar interstellar objects regularly, perhaps several times per year. Yet Oumuamua remains unique, with no comparable objects discovered since its passage. This rarity raises questions about whether such visitors are extremely uncommon or if current detection methods simply miss most interstellar objects due to their faintness or brief visibility windows. Despite years of intensive analysis using the world's most sophisticated instruments, Oumuamua's true nature and origin remain hotly debated among astronomers worldwide. While mysterious visitors from distant stars puzzle scientists, equally enigmatic forces, the Great Attractor, much larger scale throughout our cosmic neighborhood. Our galaxy is being pulled towards something massive and mostly invisible. The Milky Way, along with thousands of neighboring galaxies, races through space at tremendous speed toward a mysterious gravitational anomaly that astronomers call the Great Attractor. This cosmic force exerts such powerful influence that it affects the motion of galaxies across hundreds of millions of light years, yet its true nature remains hidden behind veils of cosmic dust and gas. Gravitational mapping conducted throughout 2024 revealed that the Great Attractor's structure spans an incredible 500 million light years across space. These measurements used advanced techniques to trace the movements of galaxy clusters and map how gravitational forces shape the large-scale architecture of the universe. The mapping reveals a complex web of interconnected structures where matter concentrates in filaments and nodes, creating the cosmic scaffolding that organizes galaxies on the largest possible scales. Our local group of galaxies moves at 600 kilometers per second toward this gravitational monster. This velocity represents one of the fastest large-scale motions detected in the universe, demonstrating the immense gravitational power concentrated in the Great Attractor region. The local group includes the Milky Way, Andromeda Galaxy, and dozens of smaller galaxies, all swept along by this cosmic current that has persisted for billions of years. Studying the Great Attractor presents enormous challenges because it lies hidden behind the Milky Way's galactic plane. This region, known as the zone of avoidance, blocks visible light with dense concentrations of gas and dust that obscure our view of distant objects. Astronomers must peer through this cosmic fog to understand what generates such powerful gravitational attraction from behind the curtain of our own galaxy. Recent X-ray and infrared observations successfully penetrated the cosmic dust to reveal massive galaxy clusters within the Great Attractor region. These specialized wavelengths pass through the obscuring material that blocks visible light, allowing scientists to map the distribution of galaxies and hot gas that contribute to the region's enormous mass. The observations show that the Great Attractor contains numerous galaxy clusters packed into a relatively small cosmic volume. Scientists discovered that the Great Attractor represents just one component of an even larger structure called Laniakea. This supercluster spans over 500 million light-years and contains more than 100,000 galaxies organized into a vast network of cosmic filaments. Laniakea's discovery revolutionized understanding of our cosmic neighborhood, showing how local galaxy motions connect to structures on truly cosmic scales. Calculations indicate the Great Attractor contains a mass equivalent of tens of thousands of galaxies concentrated in a relatively compact region. This enormous mass creates a gravitational field responsible for pulling our local group and countless other galaxies toward inevitable collision and merger events that will reshape the cosmic landscape. Despite mapping the Great Attractor's gravitational effects across vast distances, its fundamental nature remains largely mysterious to astronomers worldwide. Yet while this cosmic force operates through gradual gravitational attraction over millions of years, other phenomena in deep space unleash their power in sudden, catastrophic bursts of unimaginable intensity. Gamma-ray burst sources latest space observations. The most energetic explosions in the universe since the Big Bang tear through space with unimaginable violence. Gamma-ray bursts release more energy in mere seconds than our sun will generate during its entire 10 billion year lifetime. These cosmic detonations shine brighter than entire galaxies for brief moments, then vanish completely, leaving astronomers scrambling to understand what could produce such tremendous power. GRB 221009A, observed throughout 2024, became the brightest gamma-ray burst ever recorded in astronomical history. This extraordinary event, nicknamed the Boat for Brightest of All Time, occurred in the constellation Sagitta and shone brilliantly for approximately 10 minutes before fading into cosmic darkness. Dozens of spacecraft detected this burst simultaneously, including NASA's WIND mission, creating the most comprehensive dataset ever collected from a single gamma-ray burst. The event's incredible brightness allowed scientists to study gamma-ray burst physics with unprecedented detail. These bursts release energy equivalent to converting the entire mass of our sun directly into pure energy through Einstein's famous equation. The power output defies comprehension. Imagine taking every star in our galaxy and forcing them all to explode simultaneously. Even this comparison fails to capture the true scale of energy involved in these cosmic catastrophes. New evidence confirms that long-duration gamma-ray bursts, lasting from 2 seconds to several minutes, originate from hypernova explosions of massive stars. These stellar giants collapse when their nuclear fuel runs out, creating black holes while simultaneously launching jets of material at nearly light speed. The hypernova connection explains why long bursts often appear in star-forming regions where massive stars live brief, violent lives. Short-duration, gamma-ray bursts, lasting less than 2 seconds, present a different mystery linked to neutron-star collisions. When these ultra-dense stellar remnants spiral into each other, they create explosions that generate brief but intense gamma-ray emissions. These collisions forge heavy elements like gold and platinum, while producing some of the universe's most powerful explosions. Gamma-ray burst jets represent one of astronomy's greatest puzzles. These beams of energy and particles rocket away from their sources at 99.9% of light speed, focusing tremendous energy into narrow cones. The mechanism that creates such incredible energy focus remains completely unknown, challenging current understanding of physics under extreme conditions. The possibility that gamma-ray bursts could sterilize planets within their beam paths raises sobering questions about life in the universe. The intense radiation from a nearby burst could strip away planetary atmospheres and destroy the ozone layers that protect surface life from harmful cosmic radiation. Computer simulations conducted throughout 2025 successfully recreate many aspects of gamma-ray burst formation, yet they still cannot fully explain the energy output mechanisms. These models show matter falling into black holes and magnetic field interactions, but crucial pieces of the energy generation puzzle remain missing. Despite detecting thousands of gamma-ray bursts since their discovery, the exact mechanisms powering these cosmic monsters remain unclear. The universe's capacity for destruction on such scales makes the apparent absence of other civilizations all the more puzzling. The Fermi Paradox, updated Drake equation. Where is everybody? Physicist Enrico Fermi posed this simple question in 1950, and it remains one of science's most troubling puzzles. Given the vast number of potentially habitable worlds scattered throughout our galaxy, the absence of any detectable alien civilizations creates a contradiction that challenges our understanding of life in the universe. With hundreds of billions of stars in the Milky Way alone, many hosting planets in their habitable zones, we should expect to find evidence of other technological species. The Drake equation received significant updates throughout 2025 as new exoplanet discoveries refined our estimates of potentially habitable worlds. Recent calculations incorporate data from thousands of confirmed exoplanets, revealing that roughly 20% of Sun-like stars host Earth-sized planets in their habitable zones. However, researchers now recognize that habitability requires more than just liquid water. Plate tectonics, stable atmospheres, and protective magnetic fields all play crucial roles in supporting complex life. Studies suggest that the fraction of planets meeting all these requirements drops to just 0.002, dramatically reducing the expected number of advanced civilizations. The James Webb Space Telescope has revolutionized exoplanet research by analyzing atmospheric compositions of distant worlds. Throughout 2024, JWST identified several potentially habitable exoplanets with water vapor, oxygen, and other biosignatures in their atmospheres. Yet despite detecting the chemical ingredients for life, these observations reveal no technological signatures, no industrial pollutants, artificial lighting, or megastructures that would indicate advanced civilizations. The Great Filter hypothesis proposes that some evolutionary barrier prevents most life from becoming spacefaring. This filter could occur at any stage, from the emergence of life itself to the development of intelligence or technology. Recent research suggests that artificial intelligence might represent a particularly deadly filter. Some scientists estimate that civilizations adopting widespread AI use survive only 100 to 200 years before self-destruction, providing very little opportunity for interstellar contact. SETI searches have expanded far beyond traditional radio signals to include technosignatures across the electromagnetic spectrum. Modern searches look for industrial pollutants in exoplanet atmospheres, artificial lighting on night sides of planets, and megastructures that harvest stellar energy. Scientists even explore quantum communication possibilities, suggesting that advanced civilizations might use quantum entanglement for instantaneous communication that current methods cannot detect. Recent calculations suggest we might be among the first intelligent species in our galaxy. The universe needed billions of years to create the heavy elements necessary for rocky planets and complex chemistry. Life on Earth required nearly 4 billion years to evolve intelligence, suggesting that most potentially habitable worlds might still be developing simple organisms. Despite decades of searching with increasingly sophisticated methods and refined equations that incorporate the latest astronomical discoveries, the silence from space remains deafening. This cosmic loneliness forces us to confront fundamental questions about existence itself, including the very mechanisms that shaped our universe from its earliest moments. Cosmic Inflation Evidence 2025 Cosmological Data. The earliest moments of cosmic history hold clues to these profound questions. The universe underwent exponential expansion in its first fraction of a second after the Big Bang. This period, called cosmic inflation, stretched space itself at an incredible rate that defies normal understanding. In less than a trillionth of a trillionth of a trillionth of a second, the universe expanded from smaller than a proton to larger than a grapefruit. This rapid growth phase supposedly ended as quickly as it began, leaving behind the more familiar Big Bang expansion that continues today. Cosmic microwave background observations from 2024 provided new tests of inflation theory using increasingly sophisticated detection methods. The Planck satellite and ground-based telescopes measured temperature fluctuations across the entire sky with unprecedented precision. These measurements reveal patterns that match inflation predictions about how quantum fluctuations during the rapid expansion phase created the seeds for galaxy formation. The incredibly uniform temperature variations across opposite sides of the sky support the idea that these regions were once close together before inflation stretched them apart. Inflation theory elegantly explains the universe's large-scale structure and temperature uniformity through this rapid expansion mechanism. Without inflation, distant regions of the universe would never have been in contact long enough to reach the same temperature we observe today. The theory also explains why the universe appears geometrically flat on large scales, as inflation would have stretched any initial curvature to undetectable levels. These solutions to long-standing cosmological puzzles made inflation the leading theory for early universe evolution. Scientists continue searching for primordial gravitational waves that would provide direct confirmation of inflation. These waves represent ripples in space-time itself, created by the violent expansion during the inflationary epoch. Gravitational wave detectors like LIGO and Virgo scan for these ancient signals, though they remain extremely faint and difficult to distinguish from other sources. Detection of primordial gravitational waves would offer the strongest possible evidence that inflation actually occurred. Alternative theories challenge inflation's dominance in cosmology. Ecparodic models propose that the universe underwent a slow contraction phase before the Big Bang, creating similar observational signatures without requiring rapid expansion. Varying speed of light cosmology suggests that fundamental constants like the speed of light were different in the early universe, potentially solving the same problems that inflation addresses through different mechanisms. The fine-tuning problem poses serious challenges for inflation theory. The mechanism requires extremely specific initial conditions and parameters to start and stop at precisely the right moments. This delicate balance seems improbable, raising questions about whether inflation truly explains the universe's properties or simply pushes the mystery back to earlier times. Despite explaining many observations, direct evidence for the inflation mechanism remains elusive, leaving this cornerstone of modern cosmology as one of physics' greatest unresolved mysteries. Yet while we struggle to understand how everything began, an equally profound question emerges about cosmic destiny itself. The universe's ultimate fate current predictions. Dark energy drives cosmic expansion at rates that create fundamental disagreements between measurement methods. This mysterious force comprises roughly 68% of all energy in the universe, yet scientists cannot explain what it actually is or why it accelerates expansion over time. Recent observations suggest the expansion rate exceeds previous predictions, creating what researchers call the Hubble tension, a fundamental disagreement that has escalated into a full cosmological crisis. The Big Rip scenario presents the most violent possible ending to everything that exists. As dark energy continues driving accelerating expansion, the fabric of space itself stretches faster and faster until it overcomes all other forces in nature. First, galaxy clusters separate beyond gravitational influence. Then, individual galaxies tear apart as space expands faster than light can travel between stars. Eventually, expansion becomes so rapid that it rips apart solar systems, planets, and finally atoms themselves. Every chemical bond breaks, every nucleus splits, leaving nothing but isolated subatomic particles drifting through empty space. Heat death offers a gentler but equally final conclusion where the universe reaches maximum entropy. In this scenario, all energy becomes evenly distributed throughout space, eliminating temperature differences that drive physical processes. Stars burn out, black holes evaporate, and all motion eventually stops. The universe becomes a cold, dark expanse where nothing interesting can ever happen again. This thermal equilibrium represents the ultimate victory of disorder over organization. The Big Crunch remains possible if dark energy weakens over cosmic time or reverses direction entirely. Gravitational attraction would eventually overcome expansion, pulling all matter back together in the reverse of the Big Bang. Galaxies would merge, stars would collide, and temperatures would rise until everything collapses into a singularity. This scenario offers the possibility of cyclical universes that repeatedly expand and contract. Vacuum decay presents the most terrifying possibility, that reality itself might be unstable. Theories suggest that empty space exists in a false vacuum state that could spontaneously transition to a lower energy configuration. This transition would create a bubble of true vacuum expanding at light speed, erasing everything in its path by fundamentally altering the laws of physics. The bubble would be invisible until it arrived, instantly destroying all matter and energy. Proton decay affects the universe's trillion-year future by determining whether matter itself remains stable. If protons slowly disintegrate into lighter particles, all atoms would eventually disappear, leaving only electrons, neutrinos, and photons in an increasingly dilute cosmos. Black hole evaporation through Hawking radiation ensures that even these cosmic giants eventually disappear. The largest black holes might persist for 10 to the power 100 years, but they too will fade away, leaving behind only elementary particles and radiation. While scientists can model these cosmic endings, the universe's ultimate fate depends on physics we don't yet understand. Yet even as we contemplate the end of everything, mysteries persist in the most unexpected places much closer to home. The Corioactus Geister mystery. A mushroom that exists in only 2 places on Earth presents one of biology's strangest geographical puzzles. This peculiar fungus challenges everything scientists thought they knew about how species distribute themselves across the planet. Most organisms spread gradually from their point of origin, colonizing suitable habitats as they encountered them. Yet this mushroom defies such logical patterns, appearing in locations separated by vast oceans with no populations in between. Corioactus geister is found exclusively in central Texas and the island of Honshu in Japan, separated by approximately 11,000 kilometers of land and ocean. This extreme geographical separation creates one of the most puzzling distribution patterns in the entire fungal kingdom. No other known populations exist anywhere between these 2 distant locations, despite the presence of seemingly suitable habitats across North America, Asia, and Europe. The mushroom displays a bizarre star-shaped opening mechanism that releases spores with an audible hiss. When mature, the cylindrical fruiting body splits open like a flower, creating a distinctive star pattern while emitting a characteristic hissing sound. This audible spore release represents a rare phenomenon in the fungal world, making the mushroom unmistakable to anyone who encounters it. The sound occurs as internal pressure forces spores through the opening, creating an acoustic signature that scientists can actually record. Genetic analysis conducted on both Texas and Japanese populations revealed an astonishing discovery. The 2 groups are nearly identical genetically. DNA comparisons show remarkably little genetic variation between populations separated by 11,000 kilometers, suggesting they diverged relatively recently in evolutionary terms. This genetic similarity indicates that the populations have been isolated for a much shorter period than their vast geographical separation would suggest. Scientists propose several theories to explain this distribution mystery. Ancient land bridges could have once connected the regions, allowing the mushroom to spread before continental drifts separated the land masses. Bird migration offers another possibility, with migratory species potentially carrying spores across vast distances on their feathers or in their digestive systems. Human transport, though less likely, could have played a role through the movement of infected wood or other. Materials containing dormant spores. The species hasn't spread to similar habitats worldwide due to its extremely specific habitat requirements. Corioactus geister thrives exclusively on rotting cedar and oak wood, depending on particular tree species like cedar elm and various oaks in Texas, while requiring Japanese cedar in its Asian range. This specialization limits the mushroom to very specific environmental conditions that may not exist in other regions. The fungus cannot survive on just any decaying organic matter, requiring precise chemical conditions that develop as these specific tree species break down. Despite extensive genetic and ecological studies, how this mushroom maintains its bizarre distribution across 2 distant continents remains completely unexplained. While such mysteries challenge our understanding of life's complexity, other puzzling phenomena occur much closer to home in the most ordinary aspects of human behavior. The science of yawning. Yawning represents one of our most universal yet mysterious behaviors. Everyone yawns, yet nobody fully understands why we do it. This common human action occurs across all cultures and age groups, from newborn babies to elderly adults. We yawn when we're tired, bored, or stressed, and sometimes for no apparent reason at all. Despite being one of our most frequent actions, yawning remains a complete mystery to scientists who have studied it for decades. Neurological studies conducted throughout 2024 use advanced brain imaging techniques to map exactly what happens in our brains during yawning episodes. Researchers employed fMRI and EEG technology to monitor brain activity in real time, revealing that yawning activates multiple brain regions simultaneously. The hypothalamus, brainstem, and various cortical areas all show increased activity during yawns. These studies identified specific neural pathways that control this complex behavior, though scientists still don't understand why these networks trigger yawning in the first place. The contagious nature of yawning creates one of the most puzzling aspects of this behavior. Simply seeing, hearing, or even thinking about someone yawning can trigger the same response in observers. Research suggests that mirror neurons, which activate both when performing an action and when watching others perform it, might explain this contagion. Social cognition also plays a role, as yawning appears to spread more easily between people who know each other well. 3 competing theories attempt to explain yawning's purpose. The brain cooling theory proposes that yawning helps regulate brain temperature by increasing blood flow and cooling neural tissue. The oxygen regulation theory suggests yawning increases oxygen intake, though recent experiments have largely debunked this explanation. Social communication theory argues that yawning signals boredom, fatigue, or empathy to others. Each theory offers different perspectives, and yawning might actually serve multiple functions simultaneously. Yawning frequency increases dramatically before sleep and during periods of boredom or mental fatigue. Scientists have documented this pattern extensively, noting that yawning often occurs during transitions between alertness and drowsiness. This timing suggests yawning might help regulate arousal levels and attention, preparing the brain for different states of consciousness. Yawning occurs throughout the vertebrate kingdom, appearing in primates, dogs, birds, and many other species. This widespread distribution suggests yawning evolved very early and serves some fundamental biological function. Comparative studies across different animals reveal remarkable similarities in yawning behavior, indicating ancient evolutionary origins that predate human development by millions of years. Studies show that yawning frequency correlates with empathy levels in individuals. People with higher empathy scores tend to yawn more often when exposed to others yawning, suggesting connections between yawning and social bonding. Pathological yawning affects patients with various neurological disorders, including multiple sclerosis, stroke, and brain tumors, helping scientists understand which brain regions control this behavior. The mere act of thinking about yawning often triggers the behavior itself, demonstrating complex interactions between perception and motor control. Despite intensive research using sophisticated technology, this seemingly simple behavior continues to resist complete scientific explanation. From the smallest human behaviors to the largest cosmic forces, these 10 mysteries reveal how much we still don't understand about reality itself. Each puzzle represents a frontier where current knowledge reaches its limits, whether we're examining dark matter that comprises most of the universe or trying to explain why people yawn. These unsolved problems span every scale of existence, from quantum mechanics to galactic superclusters. The greatest scientific breakthroughs emerge from investigating phenomena that challenge our assumptions rather than confirming established theories. These mysteries drive researchers to develop revolutionary technologies, propose radical new theories, and question fundamental principles about how nature operates. Each unanswered question offers the potential for discoveries that could completely transform our understanding of physics, biology, and the cosmos itself.